Hi everyone, welcome to my YouTube channel. So in this video we are going to talk about a very interesting concept from a very interesting subject, digital electronics. So in this video we are going to talk about the topic binary codes and QR codes and barcodes. So we all have used QR codes and binary and barcodes in our day-to-day lives in shopping malls, in making payments, etc. But have you ever wondered how does this actually work? Like the internal working of QR code and barcodes? So in this video, we are going to learn more about the internal working of QR code and barcodes. Let's start. So the core foundation of QR code and barcodes are binary codes. So these are some of the factors important to learn for binary codes. Why does binary codes even matter? So reliability, speed, standardization, scalability, cost effectiveness, real world impact. So if we have to brief about each and every factor, we'll start with the reliability. So basically, binary codes consist and comprises of 0 and 1 number. Binary is noise resistant, so yeah, noise does not matter over here. Easy to distinguish as here analog signals are used, and error correction adds redundancy for safety. These will run in the further in the slide in the PPT. Speed. Digital circuits operate at nanosecond, like it scans at milliseconds. The barcode and QR code are scanned in milliseconds. Standardization. Universal Binary Encoding Standards, the UPC, EN, QR, the binary coding rules all over the world is similar. So if you scan a QR over here and in the other country, the information that you will get from the output of QR code and barcode is the same. So any scanner can read any barcode, that is true, which enables global commerce. Now we'll go with scalability. Same principles work for all data types. Your QR code stores 100x more data than barcodes. So if you have a lot of information, you go for shopping and there's a package and you have to read the information. So the shop owner wouldn't like print all the information on the package. It is stored in the QR code on the label of the package, which stores all the information in it. QR code stores 100x more data than barcodes. Yeah, that is true. Barcode stores much less data than QR code can store. Cost effectiveness, as it uses only basic digital circuits, it is really cost effective. Next is real world impact. Here it is used in supermarkets, payments, logistics, healthcare, ticketing, etc. Each and every one of these real life application you would have used once in your lifetime. You would have already used all of these in your day-to-day lives. Now, the core idea, everything in digital electronics is equals to binary. So everything in computers and digital electronics, binary is used. This is the foundation. Every barcode and QR code is simply binary data encoded as physical patterns. Digital electronics binary, which is 0 and 1, where black equals to 1 and white equals to 0. We'll learn about it later. Next, barcode internal working, step by step working. So we'll start with the encoding. The very first step for barcode is encoding. The product number is converted into binary, which is then translated into a pattern of black bars and white spaces. So, for example, we have a product number right now with me, and I need to convert it into a barcode. So, how will I do it? First, they'll convert it into binary, which is called encoding, like the decimal number system that we use, that is the human readable language. We convert it into binary, which is then translated into a pattern of black bars and white spaces. Next, the second step is scanning. A scanner emits light onto the barcode. So we need to emit the light on the barcode. The black bars absorb this light, the white bar reflects it. Here I'll show it. See, here the black bars absorb it and the white spaces in between reflect it. Next, we'll talk about the sensor, that is photodiodes. A sensor detects the varying light intensity reflected from the barcode and converts it into an analog electric signal. So the sensor detects the light intensity that we emitted onto the barcode and converts it into an analog electrical signal. Next step, digital conversion. The analog electric signal that is generated in this point from the sensor is then converted into a digital signal represented by zeros and ones. So here the analog electrical signal converts the digital signal represented here. Okay. Decoding. A digital circuit interprets this binary pattern to retrieve the original product number. A digital circuit interprets this binary pattern. So here the binary pattern is interpreted by the digital circuit to retrieve the original product number. So the final output is what we get, this original product number or the product name, the price, whatever information we wanted to display in the output, which was encoded into the barcode. Now, in the next slide, we'll talk about the real life application of barcode and a QR code. So, we'll take an example of shopping mall. Firstly, when we go to a mall, we go select products. So that is the very first step that we do. So product is selected, then we go to the cashier. Cashier scans the barcode. Then the product is identified. The price is identified by the cashier, and the cashier asks us to do the payment, and we scan the QR code at the cashier counter, and then the transaction is complete and the product is yours. So this is the basic step, but how does it work internally? So we are going to learn about that in this video. Next, barcode scanning. So the barcode visible here is this. Okay, now the internal process. Laser falls on the barcode. Photodiode detects the light and dark patterns on the barcode. Analog signal is generated as we saw in the previous slide. Then the ADC, analog digital converter, converts it to binary. Decoder identifies the product code, that is this, and the database that the output displayed after decoding it is, for example, here it is Coca-Cola 500 ml, which is of rupees 50. So in the second scene, the total calculation of all the multiple items is scanned, and the system adds up the prices, and the total is right now 250 rupees. Okay. Third is the QR payment. Cashier displays QR code on screen, and this is the URL we need to pay it, okay, from the QR code. Now what happens in the internal process of a QR? So for scanning the barcode, we emit the light on the barcode, but for scanning a QR, we use our phone's camera to scan it. Camera's phone captures QR. Image processor in the camera in our phones identifies the finder patterns. Grid alignment determines orientation, so whatever the orientation of the QR code is there is identified by the image processor. Each module extracted, black equals to 1 and white equals to 0. Binary stream, which is this. Decoder converts binary to text, which is the human readable form, extracts UPI address and amount, phone app processes payment, and bank receives the transfer from our account. Then the payment confirmation is done, receipt is generated, and the product is ours. The digital journey from product to payment. Product we buy, we select the product, barcode is scanned, price display, QR code, we pay it, and it is confirmed. Okay. Now we'll see the difference between barcode and QR code. Your input is the product barcode physical patterns. Here it is the image which is 2D. Here barcode is 1D. Sensor. Here we use photodiode and here we use camera of our phones to capture to scan the QR code. Signal conversion. Here ADC is used, which is analog voltage to digital binary. And here image processor, that is converts pixels to binary. Processing. Decoder circuits. Here combinational logics are used. Logic gates are used like AND or NOT. And here decoder circuits like pattern recognition, error correction, etc. are used. Here the output is product information on display, and here the URL or a payment link or text is generated, which is a decoded text. Here all the information is generated. Here, so key digital electronic concept used are binary codes, encoders, decoders. All of these we saw in the previous slides, we understood it. Now we'll go with the QR code decoding, pattern detection, and logic processing. So, firstly, finder pattern detection. Digital logic circuits scan for three corner squares. I'll show this. What are the three corner squares? See, here one, two, and three. It scans for these three squares first of all. Okay, so it scans for the three corner squares. Now, pattern recognition algorithm identifies the orientation. The orientation of QR code is identified, determines the angle and the position and all. Now, the second point is grid alignment. What is the size of the grid, and everything is determined by it. Now, the third one is module extraction. As we know, it is converted to binary where black equals to 1 and white equals to 0. Right now, we just need to remember this, which builds a binary matrix from grid. Fourth is format information reading. The reading format is determining error connection level, which is LNQH, which we'll see in the further slides, the error correction levels, which is a really important concept. Now, the fifth point is binary decoding. Here, here the example is given, which is really helpful for this. So binary decoding, this is a 8-bit binary digit. So here it adds up to, here as we do 2 power 0, 2 power 1, 2 power 2. So it adds up to 65 and the ASCII value is A. So it is literally converted to the ASCII value A. The binary digit is converted. Sixth is error detection and correction. So this we'll learn in the further slide in detail, the sixth point. It is a really important concept where a QR code or a barcode is tempered and how it detects the error. Here, the QR code structure. QR code is a 2D grid of modules, whereas barcode is a 1D grid of modules. Each module has one bit of data. Black square equals to 1, where white square equals to 0. Much larger data capacity than a 1D barcode. Data encoding. Here, as we saw the example before. Next point is QR code components. These are the four parts of the QR code component.